Hey y'all, I'd like to start a new series, a little bit of behind the scenes in a machine shop. So episode 1 here, we'll be doing the startup procedure, the cam work, material loading and actual cutting on the Waterjet. In our shop here, we have a Omax 1515. So let me go ahead and walk through the startup procedure with y'all. So first off, there's 5 main things whenever starting the machine up. Number 1, turn on your air. Number 2, turn on your water. Number 3, there's 3 electrical switches. So number 1's your low pressure water pump. 2 is your high pressure pump and VFD. Then number 3 over here is your servo motors and your computer. So now you can see the computer is booting up here. Well, before we do this, let's check one other thing. So top of your display here, if that's not showing right about 0, right now it's 30.4, that means it's faulted out. So you have to come down here and reset your VFD. So just hit reset there. It resets your configuration, and that takes your water pressure back to about 0 on that screen. So, and also any fault codes, we come over here to our remote control, click through these buttons till this light's green, and it's still showing a fault code here, so we'll click and see what that's about. Let's close out of this window. So what are we faulting? So it's just axis faults. So that means we come back down here, hit the black button and the green button, and now our codes is cleared there. So before we go to warm up the actual machine, right now you can see the nozzle is out of the water. So we'll submerge that so it doesn't make a big old mess. So your course adjustments for your nozzle is just going to be 1. If you hold down the 1, it slowly takes your Z-axis down. Take that just till it's just below water there. Let's come over here and make sure it's not on material. I'll help you up sure enough. So we'll have to move it over with your arrow keys or your X and Y axis adjustments here. So you can see it's moving along the X-axis right now. Now that we have moved the nozzle off of material to where it just has a clean shot into water, we can run our test now. So we will come over here to this screen, open up the test block, and hit water only, and we'll start the test. So this will actually fire the nozzle. You heard it kick on there. So while that's running, we want to check and make sure this value is approximately 48. So it's a little high, so we'll turn it down with our high pressure adjustment. You can hear the motor actually slowing down there. So that right there is where we want it. So we can end this test. So come over here on this screen, just hit the stop button. So now what we want to do is come over here to the pump only, click that, and we'll start this. This will fire the pump but not the nozzle. And you want to let this run for about 3 minutes to warm your pump up. That's first thing in the day. You don't have to do this every time you cut, just whenever you first fire the machine up. So while it's running pump only, we want to check our relief setting. So this relief number, we want it to be between 45 and 46. So right now it's a little low. So how we'll actually adjust that is down in here, there's a wing nut and that big yellow nut. So if we just adjust that, we'll see our pressure change. Right about there is where we want it. So we'll set that in place with the wing nut, and that's good to go. And like I said, there's hot water coming out of the relief valve piping there, but nothing out of the nozzle right now. So like I said, we want to let this run for about 3 minutes. Alright, so now we've surpassed the 3-minute mark, so we can stop that. We'll close out of our test screen here. Alright, now that we have the machine warmed up, let's go ahead over here and open up our layout program. This is a CAD CAM software here. It's very basic. For actually doing drawings and stuff, I recommend just doing it on SolidWorks, save it as a DXF, and we can import it. That's what I'm going to demonstrate here. So we're going to come up here to File, do Import from Other CAD. Brings up this menu. We have it on a flash drive here. We'll open up what we're going to cut. This is what we want to cut. It looks okay. So we'll do OK. Then that there is the profile, what we're going to cut. So what I like to do every time I import something from SolidWorks is we'll go up here, right click select, do all, it highlights it all. Then I like to come over here to the clean tab and we'll just run a cleaning process real quick. What it does is check for any gaps or duplicates, little errors. Sometimes in SolidWorks you can draw something and not notice it and something doesn't snap together quite right. And you can leave little tiny spaces and it kind of confuses the CAM software here. So now that we've done that, we're going to set our cut quality. So for this we're going to do a medium cut. So we're going to do Q3A on the keyboard here. And that sets our cut quality. You have anywhere from a cut quality of 1 to 5, with 1 being the coarsest, 5 being the highest tolerance, nicest finish, but 5 takes an extremely long time to cut. I find 3 to be a good medium between cut quality and speed. So for most generic tasks, I will just do a cut quality of 3. But if we're doing something like gears or something like that, we'll do 5. If we're doing a really thick material, just for rough brackets and stuff, we'll do like 1 or 2 because it speeds up the process some. But sorry, I forgot a little step. So before we do our cut quality, we're going to go up here and hit select all again. So it highlights it all. Come down here, do Q3A. That there has our cut quality. So now that we have our cut quality set, what I'm going to do is, this here is a tiny little part. I actually need to cut 8 of these, I believe. So I'm going to come over here to our, let's focus, come over here to our copy function. Then come down here, select this bottom corner here, select that, then just drag it over here nice and parallel, tap that. Then now that I've spaced it out, clicked it where I want it, it's going to ask me how many I want. So since I want a total of 8, I'm going to do 7 additional. So I'm going to click OK, and boom, there pops up our 8 tabs. Now is the little bit tricky part. So where this is such a tiny little part, if I don't either tab them or bridge them together or create little tabs to the base metal, they'll actually fall down into the bottom of the tank. So since we don't want that, we don't want to waste material, let's come over here to lead to, we're going to right click this little drop down menu and hit the create tab. And so we'll just tab it off right there, and we'll repeat for all the rest of these parts. So I'll come back in just a sec. So now that I have all of my tabs made, what we need to do is create our cut path. So we'll come over here to auto path. I like to erase all of my leads and traverses real quick, just so that it doesn't confuse the process later on. So now we'll right click and do our advanced and configure. And from this step here, it'll display, generate your path for you. It's usually pretty good. You can go down here and preview your actual drawing. You can see what it will actually do. This little menu here, you can set where the start and end is. So the green block is your start, the red block is your end. So I can make it start in this bottom left corner and if I click the red block over here, it'll change it to where it ends in the bottom right corner, so you can see how it adjusts your path. Let's say I wanted it to end in the top left corner, it'll automatically adjust our path. Oh, my bad, I made it start in the bottom. So say I want to change it to where it ends in the top left, I'll just hit the red dot here, and you can see how it has drastically changed our cut path. But I typically, most of the time, I'll start on my bottom left and end on my bottom right. That way, if say I'm doing multiple parts, multiple runs, it automatically sets it up for the next cut. There's nothing extra I have to do. If I need to get to the center of a piece of material, this right here is very handy if you want to start your cut in the center. It helps aligning your stock on the machine, but it's pretty rare that I do that. So for this cut, we're going to start in the bottom left and end in the bottom right. So everything else is good to go, so we'll hit go, and it should pop up with your cut path here. So now at this point, come over here and click post, and it's going to ask you to pick your start point. This is just kind of double checking your cut path. Then it'll preview the actual cut path. You can see the offset, so make sure that you're cutting on the right side of your line to keep tolerances and all of that. So if we zoom in here, we can see the purple line is the DXF drawing file, and then the red line is the actual cut stream of the water. So you can see that the edge of that stream of the water is going to be right up against the edge of your DXF file. You can see super tiny that it, due to the cut path of the water, cylindrical, so it can't get into that sharp tight corner, but that, I mean, that's microscopic what it's going to be missing there. But the biggest thing you want to check here is that your cut path is on the right side of your line. So similarly, we want to cut outside of the DXF here so that it's not smaller than drawn, and then we want to cut inside the line here so that this 1/4 inch hole is toleranced correctly. So all of this looks good, the preview's good, no errors, so we'll hit save. Then we'll go up here and right click post again. That'll bring a drop down menu, and we're going to hit open the path and make. And since make's already open from us warming the machine up, we'll just hit retry. And then it'll open up make. So from this point, it lets us adjust our material. So we're going to be cutting steel, so that's already set. We're going to be cutting 1/10 inch material, so we'll change this. I usually do 0.1, let's see, 0.11. I usually like to go slightly thicker than my material, just in case it cuts a little too fast. It's always cutting through the material if you're just slightly over. Oh, let's refocus here. So all of this looks good. We can hit OK, but just to demonstrate, let's say you're cutting aluminum on here, brass. It has predefined settings for basically any material you would ever cut on a Waterjet. That automatically changes your feed rates and your speeds, but we're already good with steel, so we can click OK. And cool little feature, we'll just click OK here. Cool little feature is it calculates your cut path, how long it's going to take, the amount of material used, all sorts of metrics. But these are very good for keeping records for your machine and being able to bill clients. So now that this is all set, we'll load some stock in the machine real quick and get cutting. Alright, so we've went ahead and loaded some stock into the machine. One thing to make sure you always do is be sure to clamp the material somewhere in the machine, or else the water jet, as the jet's passing through it, has a tendency to vibrate the material and it'll leave you with a rough cut or make it go out of tolerance. So what we always like to do is just these squeeze clamps here. Find a good, solid, safe place to tie her down to. So we're going to go ahead, Put it down here on this piece of material right here, and we'll just cinch it up and it'll hold it right in place. Alright, so I went ahead and clamped our stock into the machine here. I just tossed 2 of those squeeze clamps on there, hold it good and steady, nice in place. So now what we need to do is bring our nozzle over to where our cut path is going to be, set our Z0, go ahead and home it for that spot just in case any errors happen, and then we'll be ready to run the program. So how we do that is for rapid traversing you hit shift and then your arrow keys. Left and right is your x-axis, as you can see, so it's rapidly moving, and then your up and down arrows is your y-axis, so we're going to wrap it over. So now say you want some slower movement, if you use the same keys, just don't hit the shift key and it'll be much slower traverse. So we need to go up just a little bit more in our y direction. So now we need to zero our z-axis. So to rapid up and down is 7 is up, 1 is down. So right now I'm pushing the 1 key and it is rapiding the z-axis down. Once we touch the water level there, we'll go ahead and use our filler gauge here. So Omax provides us with this filler gauge. It's 60 thou. You just toss it right here under where the nozzle is going to go, and then you can come back over here to the controls and wrap it down till that filler gauge just starts to move. So there, it's starting to move, and then we can do a fine adjustment with page up, page down. That moves it in 10,000 increments at a time. So we'll rapid that down, and just like a feeler gauge for spark plugs, you just want to check it until it just gets a little bit of tension. There it's still a little bit loose. So we'll go page down a couple more times, and that has us right where we want to be. That gauge just slides right under the nozzle but doesn't really bind too much. So that's good. So we come back over here to the computer screen now that we've zeroed it on the machine. You need to zero it in the program here. So if you hit these double zeros up by the z-axis, it'll ask you if you want to zero your z counter. You just hit OK, and now that value is 0. So now what we want to do is move the jet to where we want to be on our stock. So a reminder that we're starting on the bottom left corner in our file. So we'll just move the nozzle over to give us enough room on our stock. And so for this, just in case any errors happen as we're cutting, we'll go ahead and zero our X and Y axis is up here. So we'll hit 0, it'll ask us if we want to do it, we'll say yeah, sure. So that is our new home position. Now that we have all of these set, we just need to raise the nozzle and put the sponge back on it so we don't shoot water all over the place. So what we're going to do is on the keyboard, we're just going to type in Z2 and it'll pop up this menu here. It's just a double check here. So we'll hit go, and when we hit go, it automatically raises our Z-axis. That gives us enough room to toss our sponge underneath of it. Just put this guy on real quick. This guy here helps cut down on splash as you're making your plunge cut, and helps keep down on noise a little bit. So now we're going to go over here and hit the green arrow by our Z height. It's going to ask us to traverse. We're going to select yes, and it's going to go back down to that 0 we set, and now we're ready to cut. So to cut, all you have to do on your program window is hit begin machining, come up here and hit start, and it's going now. Your pump's firing up, cut the pressure, and there it just made its plunge cut. So as it's cutting on the machine, real time over on the program, that cross you see moving is the actual position of the nozzle. You can see where it's at. So we'll come back over here. While it's running and while it's submerged, it's very difficult to see your part being cut. But if we zoom in here, we can see you can actually see your parts being cut in real time. Alright, now that our parts have been cut, let's go ahead and rapid this nozzle out away from where we cut, and we can pull those tabs off of here. So we're just going to go ahead and close out of this cut path, and that'll allow us to jog the machine around. So we're going to raise our Z-axis, get it up out of the way. Then every time I shut the machine off, I like to keep the nozzle out of the water. So we'll rapid it down to the far end, that way we can move stock in and out nice and easy. So now let me go ahead, pull this stock out of here, and you can check out the tabs we cut. Alright, now that I've removed the stock from the machine, all it really takes to pull these guys out of here is just a little bit of muscle. You can see it breaking loose already there. So, like I said, we don't have to do this where it's such a small part. It leaves, let's focus, just that little tiny burr on it there. You have to grind that off, but otherwise it's all good. The reason we have to do that is, you see the stock lays on these slats, but if what you're cutting is smaller than these slats, it'll just fall through and go into the bottom of this giant tank. We've had that happen quite frequently, so we keep a magnet on a stick and go fishing occasionally, but that's not very fun. Now that we've made our cut, to shut the machine down, you just do the reverse steps of firing it up. So remember, you have your 3 electrical switches, 1, 2, 3. And then you have your air pressure and your water pressure, and it's all good to go for the night. Everything's shut down. One last little tidbit I'd like to add in here. Contrary to popular belief, it's not just water that cuts the material. There's actually this abrasive material called garnet that is fed into the nozzle, into the high pressure stream, and that's what actually does most of your cutting. So that goes into this hopper back here. That is approximately a 100-pound hopper. So on that cut screen I showed you earlier, it shows you how much abrasive you use per cut. So I'm going to show you how to fill up that hopper real quick. So we come over here to our garnet storage and grab us a bag. Each bag is, I believe, 55 pounds. Yep. So we'll grab a bag. This one has a little tear in it, so we'll go ahead and grab it. We'll carry the bag back over here. I just temporarily set it down on top of the pump here. And then we'll pull the lid off of our hopper. And there's this screen that I like to run the material through. It catches any debris or anything that may be in the garnet. Our cap has already popped down there, so we don't have to worry about that. So we'll just take our pocket knife, put a little slit into the bag and empty it into the hopper here. It's actually a little bit leaking out there. So there we're loading into our hopper with our abrasive. This stuff's actually fairly expensive. It's about $800 a pallet. If I'm not mistaken, there's 42 bags of it on a pallet, but I don't know, you go through a bag of it about every hour or so of runtime. So just be careful when you are loading this hopper that no foreign objects or large pieces of paper or anything make it down into the hopper, because everything that goes in this hopper eventually gets fed into the nozzle, and it's very easy to clog that nozzle with any foreign objects. So that pretty much wraps up today's video on how to run a Waterjet from start to stop. If you guys like this video, be sure to comment, like, subscribe. If you like these style videos, I have a whole machine shop here with some CNC equipment, plenty of manual machines, some welding stuff down here, casting. I have a whole wood shop. So if you guys would like to keep these videos coming, be sure to let me know. Any questions, feel free to leave a comment. Otherwise, this here was our video on how to operate an Omax 1515 Waterjet. See y'all next time.